Hello everyone. Welcome to Bedtime Universe. Tonight, as the house quiets and the moon keeps its patient watch, we follow a traveler that is older than our memories, a small, cold wanderer that has crossed seas of empty space and the slow churn of stars, to arrive for a while within our sun's light. We call it 3I divided by Atlas. Others have seen its faint glow through the long lenses of observatories and the steady gaze of telescopes. Scientists have traced its path across the dark, and instruments have listened for the telltale signatures of water and ice. Tonight I will tell you what we know, what it might mean, and why the arrival of 3I divided by Atlas is as much a story of curiosity as it is of cosmic chance. Imagine a speck on the black. Imagine something smaller than a city, perhaps a relic of a distant planetary nursery, picking its way between the gravity wells of unnamed suns. For most of its life it has been alone, a frozen, silent artifact drifting through the interstellar medium. But across unimaginable distances, the push and pull of planets, the whisper of passing stars, and the slow decay of orbital motion conspire differently for every tiny body. Once in a great while, one finds itself bent into a new trajectory that brings it to visit another star. We did not always notice these visitors. Only with patient sky surveys did we begin to recognize them for what they are: travelers from elsewhere. 3I divided by Atlas first came to human attention because of an automated sentinel, the Asteroid Terrestrial Impact Last Alert System, or ATLAS. Its telescopes sweep the night, alert for moving specks that might one day be dangerous to us. On a clear night, early in July of 2025, a faint object moved where background stars did not. At first, it was only another dot in a long list, but follow-up observations peeled back the numbers. Its path was not elliptical like a comet tied to our sun, but hyperbolic, a path that would carry it through and away, not bound to our system. It was an interstellar interloper, the third reliably identified of its kind to meet our instruments. Those first headlines were quick to call it exotic, mysterious, perhaps even magical. Yet, the work that matters is quieter: careful pointing of telescopes, the steady drip of spectral measurements, and patient calculations that transform raw data into a story. Astronomers trained their optics on 3I divided by Atlas from instruments across the globe and in space, ground-based giants that collect faint photons, space telescopes that peer past Earth's air, and ultraviolet-sensitive instruments that read the fingerprints of molecules. The result was a portrait of a visitor that wears a ghostly halo, a coma, and a gentle tail, the signature of a comet. You may ask, comets are made of ice and dust. How do we know this object came from a place beyond our sun? The answer lies in its motion. Its orbit is hyperbolic, its velocity too high to be captured by the sun's gravity. This tells us it carried with it a history not formed here, and yet its behavior challenges the tidy categories we have. While some earlier interstellar visitors were bone-dry rocks or carbon-rich fragments, 3I divided by Atlas showed signs of water, or more precisely, its chemical byproducts, long before it reached the inner part of our system. Detecting water at great distances is not trivial. Water itself is not easily visible from afar, but when water molecules are excited by ultraviolet sunlight, they can break apart into fragments that emit light at specific wavelengths. One of these fragments is the hydroxyl radical OH, and its signature in ultraviolet light betrays the presence of water sublimating into gas. Instruments tuned to the ultraviolet detected OH emission around 3I divided TLASLS when it was still several astronomical units from the Sun, much farther than the distance where the familiar comets of our skies typically begin to boil off. Their ices. This unexpected activity raises a number of fascinating possibilities. First, the composition of 3I divided by Atlas might be richer in volatile ices than many comets observed in our own solar system. Perhaps it retained fragile, shallow reservoirs of water ice, protected by a porous matrix of dust that began to release when warmed slightly by the sun's reach. Or perhaps structural fragility allowed interior ices to become exposed by cracks and fractures as the body experienced mechanical stress during its interstellar journey. Another possibility is that the object contains more reactive or uncommon ices, like molecular oxygen, or trapped gases that respond to sunlight at greater distances, releasing water indirectly. Each of these scenarios tells us something different about how small bodies form and evolve around other stars. As discoveries go, this one is intoxicating because it underlines a truth. Objects that come from beyond our system are not all the same. Oumuamua, the first discovered interstellar object, behaved oddly pancake or cigar-shaped, tumbling, showing a slight acceleration without the usual sign of outgassing. Borisov, the second, resembled a classic comet, trailing gas and dust with clear spectral signals of volatile molecules. Now 3I divided by Atlas adds a third voice to the chorus, a body that seems to carry abundant water or water-bearing materials even at a far remove from the Sunday. Like the samples of a foreign land, each one hints at the variety of planetary formation processes happening across the galaxy. It is tempting in the human way to spin grander tales. Across social media and opinion columns, speculation soared. Some suggested that an anomalous signal or unexpected brightness could indicate an artificial structure. These ideas attract attention and headlines precisely because they offer drama and the promise of rewriting our place in the cosmos. But rigorous science asks for more than drama. It asks for repeatable evidence, for measurement, for cautious inference, rooted in an understanding of noise, instrument response, and the physics we know. At present, the most parsimonious reading of the data is that 3I divided by Atlas is natural. Its coma and tail are consistent with sublimating volatiles and dust. Its spectral fingerprints align with molecules we understand. That does not close the door on wonder. On the contrary, a comet rich in water from a distant system opens new chapters in our understanding of how life-nurturing materials are distributed across the galaxy. Water ice can be a vehicle for organic chemistry, for the prebiotic reactions that lay the groundwork for life as we know it. If other systems produce and scatter icy bodies like this, they participate in a shared exchange of solid matter across the interstellar medium. Let us dwell for a moment on the human reaction to such events. When astronomers announced these detections, the public consumed the story in two overlapping ways: as a headline of novelty and as an invitation to contemplate. For some, the news was a scientific curiosity, another checkmark in the catalogue of rare objects. For others, it rekindled the older myths of messages in the night, comets as omens, as heralds, as carriers of meaning. Our culture carries a deep appetite for narratives that place us at the center of cosmic action. The steady work of observatories, however, asks us to temper our narratives with measurements. The real enchantment is that the universe is subtle and diverse, and that our tools have become good enough to see its nuance. Observationally, what does it take to see 3I divided by Atlas? For the casual stargazer, the object will remain faint beyond naked eye visibility. Its magnitude, the measure astronomers use for brightness, keeps it in the realm of small telescopes and dedicated imaging. But that scarcity of visible brilliance does not diminish the value of watching. Amateur observatories, armed with modest telescopes and CCD cameras, contribute to the dataset. Long exposure photographs, careful timing, and community coordination produce positional measurements that refine orbit models and feed larger analyses. In a way, the comet invites participation. The more eyes and instruments pointed at it, the richer the story we can tell. Behind the data are the laboratories and the instruments, ultraviolet spectrometers, large aperture reflectors, and space-based telescopes. Each records a different piece of the comet's nature. Ultraviolet readings reveal fragments from molecular breakup. Infrared observations trace thermal signatures and dust, and optical spectra find the fingerprints of molecules by their absorption and emission lines. Combined, they form a mosaic. The OH emission stands out because it is a clear, interpretable sign of water being liberated, and its early detection forced theorists to confront ideas about the thermal and structural behavior of small bodies in interstellar space. Why would a comet hold onto water for so long and then only start to release it far from the sun? In the cold dark between stars, ices bind into porous structures. Collisions, cosmic rays, and simply the passage of time change their microstructure. If an object formed far from its host star, in the freeze of an outer disk, the ices may be abundant and volatile rich. But if that object also spent eons drifting in interstellar space, subtle heating during stellar encounters or tidal interactions could have altered its surface. Perhaps the outermost grain layer was friable and easily lifted by even gentle thermal stress, releasing subsurface volatiles at greater heliocentric distances than we usually see. Another thought: interstellar space is not empty. It contains clouds of dust and gas, magnetic fields, and the remnants of previous stellar winds. A body passing through varying environments might accrete or lose materials in unpredictable ways. We must also consider that our models of sublimation are calibrated to solar system comets, whose histories of formation, collisions, and thermal evolution are anchored to the Sunday. An alien comet story could include phases and processes unfamiliar to our datasets. These are not just academic details. They are the threads of a larger tapestry describing how planetary systems seed the galaxy with raw materials. Beyond the science, there is a quieter human benefit to such discoveries: humility. We are reminded that the universe hosts a variety of experiments in planet formation. Each interstellar object is a single sample from a near-infinite experiment performed by nature. We cannot, from one visitor, claim to know all the recipes for planetary systems, but we can begin to assemble a statistical picture. Some systems produce dry, scattering rocks. Some send icy messengers. Some may eject fragments rich in organics. Over time, the collection of these observations will allow us to infer the diversity of planetary architectures across the galaxy. As 3I divided by Atlas continues its passage, instruments will track its brightness, spectrum, and morphology. Scientists will watch for changes. Does the coma swell as it warms? Does the tail shift direction as dust grains respond to solar radiation pressure? Will new gas species reveal themselves as different ices begin to sublimate at increasing temperatures? Each change is a tiny revelation, a page turned in a book whose sentences are written in light. The story also intersects with the practical. As telescopes and detection algorithms improve, we expect to find more such visitors. The first 2 interstellar objects surprised us because we had not routinely been searching for them. Now, with surveys that scan the sky nightly and instruments that filter moving sources, the discovery rate is likely to increase. Each new detection will add context and complexity, and the community will refine its models. It is a thrilling time. Astronomy is not merely cataloging the night, it is opening a new branch of comparative planetology that spans the galaxy. If you imagine yourself under a wide, quiet sky tonight, think of the scales involved. 3I divided by Atlas may be only a few kilometers across, but its history spans millions, perhaps billions of years. It crossed the gravitational scapes of unknown systems, survived the radiation between stars, and now, for a brief interval, reflects our light back to us. we are the better for watching. We are participants in a conversation not initiated by us, but welcomed by our instruments and curiosity. There are questions that will stay with us. Did this object originate from a protoplanetary disk similar to our own? Does it carry complex organics formed in a cold soda straw of space? Or did it keep only the simplest molecules? Could the materials on such bodies seed young planets with the ingredients for life? These larger queries connect the concrete spectral lines, particle physics, orbital mechanics, with the existential. How common might the conditions for life be in the galaxy? Each comet, each detection, nudges our estimates and widens our frame. And yet, perhaps the most profound takeaway is simple. The cosmos is vast, and in that vastness, chance does extraordinary work. A small body set loose by the dynamics of a distant planetary system finds its way into ours, and human minds, telescopes, and instruments join together to decode its story. The process is an expression of our species' peculiar strengths: curiosity, collaboration, and the patient transformation of numbers into narrative. So, as we close our eyes tonight, let us imagine the path of 3I divided by Atlas. A slow, silent voyage through starlight that carried with it ice and dust and the frozen memory of another Sunday. Think of the photons it shed as warmth reached its shadowed regions. Photons that took hours to travel, then days, then minutes across the void to meet our detectors. Think of the teams who triangulate its position, of the software that filters background noise, and of the quiet triumph when a spectral line reveals the unmistakable mark of OH. In the weeks and months to come, more data will arrive. Models will be refined. Perhaps future interstellar visitors will overturn current assumptions. Perhaps they will confirm that 3I divided by Atlas is a rare but instructive example of a water-rich interstellar body. For now, let us savor the encounter for what it is: a brief, luminous crossing of trajectories, a natural messenger from a distant system that stopped by, for a while, to share its secrets in ultraviolet whispers. Good night from Bedtime Universe. Keep looking up, not for salvation, not for spectacle, but for the quiet, stubborn knowledge that the universe is a place of variety, and that each new object we meet tells a small part of the great cosmic story. Sleep well, and dream of slow comets and distant suns. Okay, let's go to the next story. Tonight, a new voice steps forward in the long conversation between humankind and the silent depths of space. It is not a voice of language or intention, but of light and motion, the subtle whisper of an object that has traveled farther than any road, farther than any map of our small blue home. It crossed the quiet of interstellar night, carrying ice and dust and the slow memory of another Sunday. We call it 3I divided by Atlas. This is the next story of that visitor, a careful, patient telling that blends the measured clauses of science with the softer cadences of wonder. Settle into the hush, breathe slowly, and let the tale carry you. Imagine, first, the emptiness between stars. Not absolute nothingness, but a sparse ocean of atoms, magnetic waves, and lonely photons. In that ocean drift fragments born in other systems, shards flung clear by young giants, pebbles nudged from distant belts by passing stars, and icy travelers slung into the dark by the chaotic gravitational dances of planets. Most remain forever invisible to any observer. A few, however, make a different turn. Their orbits change, their directions bend, and after eons they stumble into the luminous reach of another star. That is how 3I divided by Atlas began to be noticed by us. A faint motion against a field of steady stars, flagged by instruments meant to watch for anything moving across the night. The discovery instrument was Atlas, the asteroid terrestrial impact last alert system. a sentinel designed to spot hazardous objects. On a clear night in early July 2025, Atlas reported a faint, moving point of light. Follow-up observations by other telescopes showed a path that defied the familiar geometry of objects bound to our Sunday. Its trajectory was hyperbolic, a path not closed into an orbit but open, a line that would sweep by and never return. Its velocity was too great for the Sun to have captured it. In the language of orbital mechanics, the visitor had come from beyond. Naming conventions in astronomy are pragmatic. Official designations are precise and utilitarian. Popular names carry the charm of human shorthand. Scientists catalogued its motion, refined its orbit, and started the work of turning photons into knowledge. Observatories around the world and instruments in space trained on it. Optical reflectors recorded the faint halo of coma and tail. Ultraviolet sensors listened for atomic fingerprints. Infrared instruments measured dust and thermal properties. Together, these instruments wove the first thin fabric of understanding. What stood out almost immediately was the presence of a coma, a ghostly envelope of gas and dust, and a tail that hinted at active sublimation. In many ways, 3I divided by Atlas resembled a comet. Yet its origin was different. It arrived from the interstellar sea. And more intriguing still, it began to show the chemical signatures of water-related molecules while it was still far from the Sun, at distances where familiar comets usually remain frozen and inert. Detecting water directly across the gulf of space is rarely straightforward. Instead, astronomers look for the signs that water leaves behind when it disassembles under the influence of sunlight. Ultraviolet light can break water molecules into fragments. One of the most telling is the hydroxyl radical, OH. When telescopes tuned to ultraviolet wavelengths detected OH emission from 3I divided by Atlas. When it was still many astronomical units from the Sun, the signal suggested that water, or water-bearing compounds, were escaping the body's surface earlier than classical models predict. The realization rewired some of the early assumptions about the chemistry of bodies formed around other stars. Why is this important? Because every interstellar object is, effectively, a sample of another system, a tiny frozen archive of the conditions that prevailed where it formed. Oumuamua, the first interstellar object, detected in 2017, confounded observers with its strange shape and unexpected non-gravitational acceleration, but it displayed little of the classical cometary activity that would explain such behavior. Borisov, the second confirmed interstellar visitor in 2019, behaved much like a comet in our solar system, with robust outgassing and a nucleus enshrouded in gas and dust. Now 3I divided by Atlas adds a third variant, a visitor that, while comet-like, releases water-related compounds at unusually distant solar separations. Together, these three objects sketch a picture of diversity. Planetary systems beyond our own can produce a wide range of small bodies, from dry rocks to icy wanderers laden with volatiles. The scientific heart of this story is the dialogue between observation and hypothesis. When OH showed up in ultraviolet spectra, researchers considered multiple explanations. Perhaps 3I divided by Atlas had an unusually porous structure that trapped and preserved subsurface ices, only releasing them when minimal warming or mechanical stress exposed them. Perhaps its composition included ices that sublimate more easily at low temperatures, or trapped volatiles that release water indirectly. Another hypothesis posits microfracturing. Tiny shifts, collisions, or tidal interactions could have cracked a crust, letting interior volatiles breathe out into the void. Each hypothesis maps to different formation histories and environment signatures. Testing them requires more observation, more spectra across wavelengths, and careful modeling. Amid scientific models, public imagination surged. Social media and commentary columns amplified speculative ideas, sometimes leaping to sensational conclusions about artificiality or extraterrestrial artifacts. Such speculation feeds headlines, but rigorous science remains anchored to evidence. The balance is honest. Extraordinary claims demand extraordinary evidence. So far, the preponderance of measurements supports a natural origin for 3I divided by Atlas. Its coma, tail, and spectral signals fit within the known physics of volatile sublimation and dust dynamics. That conclusion does not dull the mystery. On the contrary, it deepens it by opening a window into the range of natural outcomes in planet-forming systems across our galaxy. To fully appreciate the arc of 3I divided by Atlas, consider the physical processes at play. A comet's display, the swelling coma and streaming tail, stems from sunlight heating its surface, causing ices to vaporize and release entrained dust. Solar radiation pressure pushes small particles into a tail that points away from the sun, while the plasma tail forms under the influence of the solar wind. Close to the sun, the thermal input is intense and the transformation rapid. But at distances of several astronomical units, where 3I divided by Atlas began to show activity, the sun's heating is muted. Why then does activity appear there? One answer is composition. If the object's ices include more volatile substances, ices of carbon monoxide, carbon dioxide, or other gases that sublimate at lower temperatures, these could drive outgassing at distances where water, ice alone remains stable. Alternatively, water ice could be released through the breakup of clathrates or complex ices, or via chemical processes triggered by cosmic radiation. The role of porosity and thermal inertia also matters. A porous structure insulates deeper layers, preserving ice until a small change exposes a region in which sublimation proceeds. Each mechanism casts a distinct chemical and morphological fingerprint, and peeling them apart requires patient, multi-wavelength observations. This is precisely what astronomers set out to do. Ground-based observatories, space telescopes, and dedicated spectrometers combined their data. Optical images traced the shape and brightness of the coma. Infrared observations constrained the size and temperature of the dust. Ultraviolet instruments charted the presence of fragments like OH that hint at water. These instruments are complementary lenses on the same phenomenon. The result was a layered narrative, an object on an unbound trajectory, showing comet-like activity and releasing water-related molecules far from the warming grasp of our Sunday. Beyond the immediate science lies a larger philosophical thread. 3I divided by Atlas reminds us that the galaxy is an active, interacting system. Planetesimals and comets are not static monuments. They are shrapnel of planetary evolution, cast off during cataclysmic rearrangements. Planet migration, gravitational scattering, stellar encounters. These dynamical events fling bodies into interstellar space. In doing so, they seed the galaxy with material that bears the chemistry of its origin. When such an object visits another system, it carries proof that the processes that create planets and minor bodies are not unique to our own corner of space. There is, too, the practical human element. Discovering and monitoring such an object is possible only because of global networks of observers and coordinated collaborations. Amateur astronomers contribute astrometry and long-exposure images. Professional facilities bring high-resolution spectroscopy and calibrated photometry. Data pipelines convert raw numbers into models of composition and motion. The emergent picture is collective, a chorus of instruments and minds converting tiny flashes of light into a story that spans parsecs. For the casual stargazer, the arrival of 3I divided by Atlas is a moment of inclusion. It is a reminder that meaningful discoveries need not be the provenance of a single giant telescope. Community science, distributed observation campaigns, and rapid data sharing allow enthusiasts and professionals alike to participate. Observers can track its changing brightness, capture images for archival study, and contribute measurements that refine orbital models. In the modern age, astronomy is a shared craft, and interstellar visitors are the rare events that draw that community together. As the narrative of 3I divided by Atlas continued to unfold, scientists watched for change. Comets are dynamic. Their behavior evolves as they approach perihelion and as sunlight alters their surfaces. Would the activity increase as it drew nearer to the Sun? Would new molecular species appear in spectra? Would dust production surge? The answers to such questions inform models of interior structure and composition. They also help compare interstellar objects with the comets we have long studied within our system. Another dimension of the story touches on astrobiology. While it is premature to claim that comets directly seed life, they are important carriers of organic molecules, the complex chemistry that precedes biology. If interstellar objects carry organics or water, they become vectors for the distribution of life's raw materials across the galaxy. The presence of water in 3I divided by Atlas at comparatively large distances suggests that volatile-rich bodies could be common outcomes of planet formation elsewhere. The implication is profound. The galaxy may harbor many more reservoirs of life's essential ingredients than previously assumed. Of course, caution is necessary. One or even a handful of interstellar visitors cannot define universal conditions. Each detection is a data point in an enormous parameter space of formation environments, collisional histories, and migratory dynamics. Yet the accumulation of such data points allows the scientific community to build statistical models. If future surveys more sensitive, wider, and continuous reveal dozens or hundreds of interstellar bodies, we will move from isolated case studies to comparative planetary science on a galactic scale. There is also a cultural resonance to these encounters. Comets and meteors have long been woven into human myth. Omens, messengers, symbols of change. Scientific understanding gradually displaced superstition, but did not erase the deep human reaction to seeing a new celestial object cross our sky. 3I divided by Atlas joins a lineage of visitors that have inspired poets, philosophers, and curious minds. It prompts us to imagine the unseen forces at work in distant planetary nurseries, and to feel, for a moment, the ephemerality and interconnectedness of cosmic things. Let us return, now, to the specifics, the instruments and their findings. Ultraviolet spectroscopy revealed OH emission, a proxy for water at distances near 3 astronomical units and beyond. Optical imaging showed a diffuse coma and the early formation of a tail. Infrared data constrained dust properties, suggesting a mix of fine grains and larger particles. Combined, these observations indicated active mass loss at an epoch when many solar system comets remain inert. The estimated mass loss rate, though subject to uncertainty, pointed to substantial volatile release, perhaps tens of kilograms per second during peak activity phases. These are not trivial numbers for a small body. They indicate a reservoir of material capable of sustaining visible activity. What does such mass loss mean for the object's future? For comets, activity can alter rotation, expose new regions, and even fragment the nucleus. If 3I divided by Atlas experienced localized outbursts, sudden jets of gas and dust, its morphology could change rapidly. Observers monitored for such events, photographing its coma and tracking asymmetries that betray directional jets. Each asymmetry is a clue, a map to the locations and behaviors of active vents on the surface. Beyond the dynamic behavior, astronomers modeled the object's origin. Backtracking its incoming trajectory points to a random direction in the galactic plane, making precise provenance difficult. Interstellar objects lose information about their birthplaces over time, their paths perturbed by gravitational encounters. Even so, statistical arguments suggest they likely originate in the outer reaches of planetary systems regions where ice-rich planetesimals form and where gravitational perturbations can eject them. Thus, 3I divided by Atlas becomes a messenger from some far-off protoplanetary disk, its chemistry a whisper of remembered conditions. In the months following discovery, the public appetite for updates remained ravenous. Scientists responded with careful press releases and peer-reviewed preprints. Data were shared openly. Telescope teams coordinated observation schedules. Citizen scientists participated in imaging campaigns. The tone of public communication aimed to balance excitement with restraint, to convey the wonder without overstating the certainty. That scientific prudence belongs to the story too. Understanding grows not by flamboyant assertion, but by the slow accretion of verified facts. As the comet moved along its unbound path, it approached perihelion and then receded, following the curve dictated by its initial hyperbolic excess velocity. Its closest approach to the Sun and the Earth would not pose any hazard. The object's path kept it well beyond dangerous proximities. Yet, the value of its visit lay not in threat, but in information. It was an opportunity to add a new specimen to the sparse museum of interstellar materials we have been able to study. Imagine, for a final stretch in this telling, the cosmic timeline telescoped into a single breath. The small body formed in a disk circling a young star, gathering ices in the distant cold. Over millions of years, gravitational nudges sent it on a path outward, perhaps launching it to interstellar space during a period of planetary reshuffling. It drifted for eons through the dark, battered by cosmic rays, and preserved its volatile inventory in porous layers. Then, by an alignment of chance, its trajectory intersects our sun's reach. For a brief human-scale moment, instruments on our world collect its light. Scientists decode its chemical traces. Communities of observers contribute pictures and measurements. Then it continues onward, receding into the night. A tiny, restless traveler resumed. What do we carry away from this encounter? Not a final answer, but a series of refined questions. How diverse are interstellar minor bodies? What do they tell us about the ubiquity of water and organics in the galaxy? How effective are current detection systems, and how might we improve them to catch more such visitors? Each question is an invitation to better instruments, international cooperation, and public engagement with the slow work of science. And so the next story, the one you have just heard, ends with an open line. 3I divided by Atlas has left us with more to think about than it removed. It has reminded us that planetary formation is not a closed, isolated process, but part of a wider galactic ecosystem, where materials and history can travel and be shared. It has reaffirmed a truth older than astronomy, that to know is to be humbled by the scale of things, and to be exhilarated by the small, luminous clues we can gather. If you look up tonight, find a place where the sky darkens, and imagine a small, bright point that was once warmed by another star. Imagine the faint tear of its coma, the spectral signatures mapped by ultraviolet light, and the scientists who turned numbers into narratives. In that image lies a cultural and scientific bridge between distant stellar nurseries and our curiosity-driven community. The cosmos continues to hand us gifts in the form of these brief, revealing visits. This is not the end. It is, as the title promised, the next story. More will come, more discoveries, more interstellar visitors, and more chapters in the slowly unfolding book of planetary systems beyond our own. For now, keep the wonder alive. Let curiosity be your companion. Let measured skepticism be your guide. Above all, let quiet attention the patient kind, fostered by telescopes, by data, and by nights under the stars, be the place from which you listen. Thank you for listening to the next story. If you enjoyed this narrative, consider sharing it with friends who love the slow, patient magic of space. Keep watching the skies, and keep asking the questions that lead us to learn. Good night. This next story unfolds like a slow river of light, flowing through the galaxy and straight into your imagination. It is not rushed. It does not demand, only offers its calm, like the night sky itself. Begin by picturing yourself under a truly dark sky, no city glow, no neon signs, just you, the quiet earth beneath your back, and above you a pale river of light. That soft ribbon is the plane of our Milky Way, the view from inside our own spiral home. We are looking edge-on through a grand disk of stars, hundreds of billions of them, each one burning in perfect, silent persistence. If the night is clear, you'll notice mottled patches and dim lanes where dust clouds drift, sculpting the light into curtains and folds. That hazy beauty is not far away. It's our neighborhood, our address in the cosmos, and lying beneath it, you can almost feel the galaxy breathe. Let your attention rest on a single star. It looks steady to your eye, a silver pin, yet that small light is a sun, with weight and heat and years enough to send you its glow across gulfs so wide they blur into time. The light you see left that sun long ago. It traveled quietly, never hurried, slipping through space until, tonight, it touches you. In this moment, you are reading an ancient postcard. Whatever your day held, messages, tasks, worries, none of them can chase light across years. You are safe here, held inside an old, patient story. Now, soften your gaze. The familiar patterns return: Orion rising in the cool months, Cassiopeia poised like a simple crown, the Big Dipper pouring toward the horizon. We call them constellations, but they're more like gentle chapters in a sky-wide book. Their shapes are not fixed. Over immense spans of time, stars drift with unhurried grace, rewriting the outlines of hunters and queens. The sky, you know, is a snapshot in a long, serene dance. Even change, on these scales, is tranquil. Let's wander inward, between the stars, into the interstellar medium space that is not empty but filled with thin veils of gas and dust. Imagine clouds so vast that a beam of light crosses them for years, and yet so delicate that a teaspoon of air on Earth holds more particles than a kilometer of that cloud. In these gauzy nurseries, gravity does its quiet work, tugging gently, gathering specks into clumps, clumps into knots, knots into hot, shining beads. A star is born not with a shout, but with patient accumulation, one grain, then another, until fire begins and a new light joins the river. Out at the edge of your vision, a blur blooms. The Andromeda galaxy, our great neighbor. Its glow set out toward us when early humans were first finding their stride. Andromeda is huge, a trillion stars washing together into that single soft smudge. You can stretch out a hand and, with a fingertip, cover an entire island of suns. And in that gesture, you learn something gentle and important. The universe is vast, yes, but it is also reachable to the heart. Even a faint smear of light can carry the weight of millions of worlds and arrive as a whisper that says, "You belong here." Every so often the night sprinkles a brief spark, one thin line, then gone. A meteor is often a grain of dust surrendering to our sky, brushing the air so quickly that it burns, writing a single glowing sentence and fading with perfect timing. We pass through these dusty trails each year, and the heavens answer with showers that arrive like annual lullabies. Perseids, Geminids, Leonids, each with its own subtle rhythm. If you've ever made a wish on a shooting star, you've practiced the oldest astronomy, paying attention and letting wonder open a door inside you. Turn to the moon now, a familiar companion, gentle and constant. Watch its phases flow, a fine silver thread, a letter D, a chalky coin, a lantern strong enough to throw shadows across fields. Its light is sunlight, softened sunlight that has touched dust and old lava plains, bounced back and draped the world with milk. The moon's pull cradles the oceans into tides and, in a way, cradles us too. When its bright face climbs your window, you can almost hear a rhythm, slow as breath, reliable as sleep. And the wanderers' planets write their own calm notes across the sky. Venus glows like a candle held close. Jupiter steadies itself with a kingly brightness. And if you peer through a small telescope, you may see its 4 major moons, little pearls in a line, changing positions night to night in a miniature ballet. Saturn appears with a restrained majesty, its rings a thin hymn around a world of pale gold. No rush, no clamor, just orbits drawn with patient ink. Near the tops of the world, and near the bottoms too, the sky sometimes sings in color. Curtains ripple green and pink, as if the night has grown translucent wings, the aurora. Charged particles stream in from the sun and meet our air. Atoms glow, and the darkness becomes a living thing. You stand under it in winter, boots crunching, breath clouding, and you feel the quiet of cold, and above that quiet, a moving light that seems to breathe with you. There are places in the cosmos where matter thins, where entire superclusters give way to great, gentle voids. Imagine drifting through one of those vast clearings, where galaxies are rare and the dark is almost perfectly deep. Solitude there is not loneliness, it is spaciousness, the universe giving itself a wide, calm room. In such places you learn that emptiness too can be generous. Beneath everything hums a background, an ancient glow stretched into microwaves, the after warmth of a young cosmos cooling enough to let light slip free. It is everywhere at once, a faint blanket cast over all of space. Knowing it's there is like discovering that the house you're resting in has a heartbeat in the walls. A soft, steady reminder that everything began warm and bright, and has been unfolding, unhurried, ever since. Planets form the way rest arrives, bit by bit. Dust collects into pebbles, pebbles into rocks, rocks into bodies that sweep the path clean as they grow. Heat sparking, surfaces softening, atmospheres gathering like sighs. Millions of years pass without any need for hurry. And out of that patience come worlds some icy and blue, some stormy and striped, some silent, stony, and ready to cradle a tiny lake or a future footstep. Gravity is the quiet law that keeps every promise. It tucks you into your mattress while it conducts galaxies in sweeping arcs. The same pull that sets tides and bends starlight is the soft insistence you feel when you choose to stay, to rest, to let thoughts settle like snow in a still globe. When you exhale, you can almost feel gravity smooth the air over you like a blanket. Remember too, the silence. Space carries no sound, no echo of flame, no rattle of stones, only the choreography of light and gravity and time. If you've ever stepped into a forest after snowfall and felt the whole world hush, the sky's silence is that, multiplied until even your worries feel embarrassed to speak. In that quiet, the mind does not need to be loud. It can simply note, I am here, I am safe, I am small, and that is peaceful. Out beyond, quasars blaze distant, powerful, and by the time their signals reach us, very gentle. Their energy has been spread thin across unthinkable distances, arriving as a faint, ancient murmur. Even the universe's most dramatic events soften with time and space, teaching us that intensity can fade into harmony. During the day, the stars are still above you, wrapped in blue. They do not leave. They wait. That constancy is a kindness. The sky is never truly empty, merely veiled. If you were to rise above the air itself, you'd see them again, steady and honest, even while the sun stands bright. What is hidden is not gone. What is quiet is not absent. The Milky Way and Andromeda drift toward each other, and in a few billion years they will overlap, swirl, and settle into a new shape. It will look dramatic if you could watch it sped up, but in real time, it is a slow waltz stars, mostly slipping past stars. Night after night, century after century, until a new, larger calm emerges. The universe is an artist who never hurries. Every stroke is patient. Between clusters, the dark grows cool close to the coldest temperature nature allows. Think of that not as harshness, but as a perfect stillness, a room kept for deep rest. In such quiet cold, heat is precious, and every small glow, every candle star, feels like a friend. Stars live and stars rest. Small red ones sip their fuel for ages. Big blue ones burn with brief, brilliant vigor. Sun-like stars one day puff gently, shedding their outer layers into glowing shells that hang like lanterns in the dark planetary nebulae, delicate and short-lived on cosmic scales. Brief artworks, exhaled by a life well spent. The cores cool to white dwarfs, embers that shine on in peace. From the ashes of heavier stars, new elements scatter iron for blood, oxygen for breath, carbon for softness and sweetness. We carry star stories in our cells. There is a mystery woven into the fabric of space, a pressure that urges everything to drift apart a little faster than gravity would prefer. Dark energy, we call it, a name that is really an open door. You don't need to solve it to be soothed by it. It is the universe's long, slow tide, out, 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 a promise that there is room to grow. For all of human history, we have looked up for direction. The North Star steadies our maps. Bright seasonal stars frame our harvests and our voyages. Even now, when satellites whisper us our coordinates, the sky remains a strong, simple compass. Look north, there is Polaris. Look east before dawn. The zodiac lifts another bright traveler. Guidance doesn't have to be loud to be true. Each observation we make, each sketch of a moon, each exposure of a distant cluster, each faint line in a spectrum is a page gently turned. The universe is a book with no last chapter, and somehow that is the most restful thought. You are not late to understanding. You are simply here for your part of the reading, and that is enough. Cosmic rays drift through all this, a fine, almost transparent rain of particles from faraway fireworks. They pass largely unnoticed, reminders that even in stillness there is a subtle exchange with the wider world. Quiet does not mean nothing is happening. Quiet can mean everything is happening without asking anything from you. Time, on these scales, is soft. It stretches, it flows, it forgives. Stars measure it in millions of years, galaxies in billions. When you hold your life against that canvas, worries shrink to manageable size. There is space to breathe. There is permission to rest. Lift your eyes once more and let them fill with starlight. See how the sky does not demand, it only offers. The longer you look, the more it gives faint clusters at the edge of vision, a dark lane you hadn't noticed, a slow satellite crossing like a moving punctuation mark. If your thoughts begin to wander, let them. If your breath slows, let it. If sleep approaches like a tide, welcome it. As you lie back under this wide, serene ceiling, remember, you are built from ancient light and cooled fire, from the dust of old suns and the water of wandering comets. The laws that hold galaxies together hold you together, gently and without fail. You are not separate from the night. You are a chapter of it. Let the darkness now be a cradle. Let gravity tuck the blankets. Let the moon stand guard at your window, and let the stars hum their silent melody, each one a distant lamp kept lit for you. There is nothing you must solve, nothing you must fix, nowhere else you need to be. The universe has been unfolding for eons without hurry. And tonight, it invites you to practice the same grace. Breathe in and out. Feel the floor steady beneath you, the air cool on your skin, the quiet curve of your own pulse. With every gentle breath, the sky seems closer, as if leaning down to listen. Allow yourself to drift. The constellations will keep watch, the planets will move on their patient paths, and the river of the Milky Way will flow on, low and silver, until morning. Thank you for wandering with me across this calm, lantern-lit ocean. May your sleep be deep and unbroken, your dreams spacious and bright. Until we meet again beneath the quiet stars, keep looking up. Keep your heart open to wonder. And rest, knowing the universe holds you softly in its endless night. And now, as the night grows deeper and the world grows quieter, let us drift into our next journey. A story carried on the darkness above us, a story written in light. Tonight, we will follow what poets once called a river across the heavens, a gentle current of stars flowing silently through the sky. This story is called The Quiet River of Stars. Close your eyes and picture a place without the noise of lamps or screens, a place where the air settles cool on your skin and the horizon is a clean black bowl. In that bowl, the river appears soft, milky, faint at first, as if someone brushed white chalk from one horizon to the other. This is the band of our own galaxy seen from within, a sideways view of the spiral disk that holds us. People have named it for as long as we have looked up. A road of light, a milk spill of the gods, a path for souls, a sky river. Astronomers give it a simpler name, the Milky Way. But names are just doors. The wonder is what you feel when you step through. If your eyes are dark adapted, 20 minutes without bright light, no phone, no car, headlights, the band lifts itself out of the background. You begin to notice texture. The river is not smooth. It is threaded with dark inlets and quiet eddies where the light thins. Those are not holes at all, but lanes of interstellar dust, thin as smoke and wide as light years, drifting between the stars and absorbing their glow. Along the band are brighter knots and hazy patches where new stars are kindling inside clouds of hydrogen. Somewhere near the middle, low on a summer night in the south, the river swells into a soft bulge. That is the direction of the galactic center, toward the constellations Sagittarius and Scorpius, where the star clouds are dense and the dust lanes cut like long black rivers within the river. We stand on a small world circling a very ordinary star. Our sun is a yellow-white dwarf among hundreds of billions, set out on a suburban lane called the Orion Arm. Some call it the Orion Cygnus Arm, or simply the local arm, a minor spiral lane between two larger ones. Perseus on one side and Scutum Centaurus on the other. From this neighborhood, we look edge-on through the disk, and the light piles up, star behind star, until the sky looks like spilled milk to the human eye. If you could jump out of the galaxy and look from above, you would see the disk as a broad spiral about 100,000 light-years across, with the sun not at the center but off to one side, roughly 26 to 28,000 light-years from the core. Numbers can feel large. Let them slow your breathing. A single light-year is the distance light travels in a year. The starlight taking shape as that pale band tonight began its journey long before your grandparents were born, and in some parts of the band, long before humans ever spoke. There is a black heart at the center, but not empty dense. A supermassive black hole we call Sagittarius A*, about 4 million times the mass of our sun, sits in the core like a city's weight under all the light. Around it, the bulge is crowded with old stars. Their orbits are tight, their dances swift. Astronomers have watched some of those stars loop the black hole in short centuries and decades, their paths bending under a gravity that is both invisible and absolute. You cannot see any of that from a dark field, of course. What you see is the echo, The middle of the river grows brighter and wider, and the dust lanes cut across it like slow thunderheads. Downstream and upstream from that swelling, the band thins and threads through the constellations like a silk ribbon, through the tail of Scorpius, through the teapot shape of Sagittarius, up past the eagle Aquila, across the bright cross of Cygnus and its long tail to Deneb, curving toward Cassiopeia's crooked W in autumn, and back down through the horns of Taurus in winter. Listen to the quiet of that river. Beneath its light is a weather of gas and dust, mapped not by clouds and rain, but by faint glows at specific colors. Hydrogen, breathing in a deep red, we call H-alpha. Oxygen in a soft teal, dust grains scattering blue like smoke. The glow is not a roar, but a whisper. New stars form in cocooned nurseries. The Orion Nebula, a flowering knot in the sword of Orion. The Carina Nebula, bright and knotted in the southern sky. The Lagoon and Trifid in Sagittarius. Side by side, one, a wide pool of glowing hydrogen, the other, a pale blossom banded by dust. In those places, gravity gathers gas until the pressure and temperature rise high enough for hydrogen to fuse into helium and light, and a star is lit. For millions of years, radiation and stellar winds carve caves and pillars out of the clouds, and when the most massive stars end, they end with a generosity that shakes their neighborhoods. A supernova enriches the surrounding gas with heavier elements, the stuff of planets and rock and you. The river recycles. The river teaches the same old lesson softly. Endings and beginnings are parts of one flow. Where you stand matters. At mid-latitudes, the Milky Way arches like a great bridge from south to north in summer. In the tropics, the core climbs high, and the river thickens overhead, finer texture, more star cloud, more dark lane. In winter, the band tilts, and though the core is hidden on your side of the planet, the river still threads through Orion and Gemini, lace-fine and quieter. From the far south, different reaches are revealed. The Southern Cross standing near the riverbank like a marker. We forget, under city domes and office ceilings, that the sky changes with season and latitude. The river reminds us if we let it. The facts can be gentle if we speak them softly. The disk that makes this band is not flat as a plate. It is warped, as if a slow hand had lifted its edges unevenly. The sun and its planets ride a wavy midplane, dipping above, then below the disk, over tens of millions of years. Our star orbits the center at roughly 200 kilometers per second, and a full lap around the galaxy, the so-called galactic year, takes something like 200 to 250 million Earth years. Think of that. One slow turn of the river's wheel, and the calendar on your wall is emptied 1,000 times. In that span, continents drift, mountains lift and wear away, new languages are born and forgotten, and the sky rivers for every creature who looks up is both the same and not quite the same, because our vantage point is always moving, always slightly changed. Far beyond the disk are the globular clusters, old and round, each a ball of ancient stars, hundreds of thousands gathered into spheres that drift in the galaxy's halo like lanterns at a festival. They are not on the river itself. They are like lights hung in high trees along the banks, thick with red giants and blue stragglers. Their chemistry, old and spare. Look for M13 in Hercules, a hazy cotton knot with a steady heartbeat of stars. Look for 47 Tucanae in the south, a larger, brighter hive of sun candles, densely packed. Those clusters are fossils of early times. The river runs newer in the disk, where gas still pools and stirs. There is a quiet address you can memorize if it helps you sleep. You live in the local bubble, a kind of low-density cavity in the interstellar medium, likely carved by ancient supernovae long ago. That bubble overlaps with your neighbor's bubbles like soap suds, and on its walls, new stars have been born and will be born. You live in the Orion Arm, part of a barred spiral galaxy roughly a third of the way out from the center. Your sun is one of hundreds of billions. Many of those stars have planets. We know this now not as a guess, but as a repeated measurement. a song of small dips in starlight, of tiny wobbles and split spectral lines that mean a world is tugging. Somewhere, on some night under a different sky, someone could point up and trace their own river, and know that a small world is looking back, equally curious and equally tired in the good way of a long day's end. Turn your mind along the river's route and let it walk by landmarks you may know in name even if you've never seen them raw. There is the Great Rift, a long chain of dust lanes running through Cygnus, dimming the river and dividing it into two pale streams. There is the North America Nebula, a red map of a continent in hydrogen glow. There is the Aquila Rift, a darker branch. The star clouds of Scutum, the small, bright M24, sometimes called the small Sagittarius star cloud, like a window where the dust thins and you can see deeper than usual. There is the Pipe Nebula in Ophiuchus, a simple L-shaped darkness that stands out simply because it has the courage to be black against all that light. Each one is a piece of texture. Each one is a reminder that the river's softness is made of millions of hard-edged facts. If you lifted above the river, if you climbed out of the disk and looked back, the band would fold itself into a grand design. A central bar, spiral arms unwinding, star formation, tracing those arms like frost blooming along glass. Tidal interactions with small satellite galaxies tug on the edges. The Magellanic Clouds leave a stream of gas, like a wake on the galaxy's sea. Dark matter unseen, but weighing far more than all the stars, holds the whole structure together, an invisible frame carrying most of the mass. You do not need the details to rest. It is enough to know that the quiet you feel beneath the river is supported by something strong and steady. And there is a future even for rivers, long from now so far that it occupies the part of the mind where fairy tales live. The Andromeda Galaxy and the Milky Way will draw together. They already are. Andromeda is coming toward us slowly in human terms, and quickly in cosmic ones. In several billion years, the two spirals will begin to interpenetrate and merge. It will not be a crash of suns. The spaces between stars are so large that very few will meet head-on. Instead, orbits will reshape, gas will rattle and compress, bursts of star formation will ignite, and the final result will be a new, larger galaxy with a new shape, a new river. No one you know will be there to see it, but somehow the knowledge feels soothing. Even grand structures have arcs to their stories, and change at that scale is a tide you can let lift you into sleep. Perhaps you are listening from a city, and the river is hidden behind a dome of light. That is all right. Part of the story of this river is that it is patient. It has waited for eyes to look up in deserts and on ships, and in mountain meadows, and on quiet balconies, when the power went out and the night returned to its ancient depth. If you ever find yourself somewhere dark on a beach after the moon sets, on a hillside at 2 in the morning, on a ferry deck where the wind keeps you awake, give your pupils time. Turn off the lamp. Let the cones in your eyes rest. Let the rods take over. Let the glow sharpen. At first you will see grey. Then the grey will thicken into a woven cloth. Then a dark seam will run through it, and a bright knot will appear, and another, and the river will be there, in a way no photograph can quite teach. Breathe in, and let it lay a hand on your shoulder. If you want a simple ritual to bring you closer to the river from anywhere, try this. Imagine your mind is a slow raft. Set it upon the band of light and let it drift. As you float, count gentle truths instead of sheep. 1. The light of Deneb has been traveling for more than 1,000 years to reach you. It left the star when empires were drawing new borders on parchment and never stopped. 2. The sun is circling the galaxy. Tonight you moved many thousands of kilometers around the center without feeling a thing. 3. The atoms in your blood were made in stars. The iron in your hemoglobin was built in the core of a dying sun before the Earth existed. 4. Somewhere deep in the band are clusters where stars are born every year from dust and gas, their infant light pushing away the very clouds that sheltered them. 5. The river you see is the edge-on sum of 100 billion worlds, all real, all turning, all warming their own nights. By the time you reach 6 or 7, you will feel the river pulling on you in the way a lullaby does, not with force, but with belonging. It is not just sight that brings you into the river's quiet. There is the sense of scale, spacious in a way that gives room to whatever you carried to bedtime. A worry that filled your whole day can sit on the riverbank for a while, not gone but smaller against the spread of things. There is the rhythm of cycles, short and long, your breath, the beating of your heart, the rotation of the earth, bringing night and day, the sweep of the moon around us, tracing tides. The path of the earth around the sun, bringing seasons. The sun's path around the galaxy, bringing epochs. The galaxy's future dance with its neighbors, bringing transformations. Each cycle holds what came before. As you listen, you are held too. For those who like details tucked under the pillow, there are a few more to rest on. The disk of the galaxy is not just stars. It contains spiral waves, patterns where gas and dust compress and release as they orbit, like cars bunching and separating on a ring road. Where the wave compresses, star formation lights up, and the arm looks brighter. Between arms, the light softens, but does not end. The dust lanes are not dirty. They are the raw material for future light, and they redden starlight, passing through them the way a sunset reddens the Sunday. On clear, moonless nights, observers in very dark places can see the zodiacal light, a faint triangle along the ecliptic, sunlight scattered by dust within our own solar system, the Gegenschein, an even fainter brightening opposite the Sunday. These small additions are like fireflies near the bank, joining the river but separate from it. If rhythm helps you rest, we can set the story to 1. The river rises in the south, flows up through the Eagle, crosses the Swan's back, passes the Queen's chair, and falls again toward the Hunter's belt by winter, then settles, then returns. With every return, you are a little older, and so is the light you see, but the pattern holds. This is the part of astronomy that feels like a kind hand. The sky is not a puzzle to be solved and set aside. It is a companion you can visit. The more you learn of its facts, the more it rewards you with feeling. Knowing the name of a nebula does not steal its mystery. It adds a note to a chord you already love, and still, beneath all the texture and all the numbers, there is the simple act of lying back and letting the white band pour across you. Somewhere along that band, on a small world with a name we have not learned, another listener may be doing the same, letting their mind drift along their river, counting their truths, thinking their own future, and carrying their own day into the kind night. When you share the river, you share something large without needing to own it. The light is given freely. The time was paid long ago by the stars themselves. If you find your thoughts wandering to distances and durations, let them. Let the mind take a slow walk. Light crossing the space between stars, collapsing gas, warming into stars, planets taking shape from rings of dust, like snowflakes growing on a windowpane, oceans forming, air thickening, creatures lifting their eyes. None of this is rushed. The river has room for slow stories. Your story is one of them. Now the night grows deeper still, and the world grows quieter still, and the river goes on doing what it has done since before there were people. It gathers the light of uncountable suns into a band we can understand at a glance. Not everything has to be solved. Some things are here to be trusted. The Milky Way is one of them. You can rest beneath it without finish lines or arguments. It will still be flowing when you wake. So breathe in and breathe out, and let the quiet river of stars carry you. If your eyes are closed, picture that soft band and the dark lanes braided through it. Picture the bulge low on the horizon, like a slow sunrise of far-off suns. Picture the way it arches up and over, east to west, season to season, age to age. If your eyes are open and lucky enough to be in the dark, let the band have you whole for a minute. Let it make every small noise in your life seem smaller, and every kind thought seem larger. In the end, that is what the river is for. It is a reminder that we live inside something vast and patient and ongoing, and that our days, bright, messy, dear, are carried along by a current we can trust. When you are ready, you may set your raft against the bank and step into sleep. The river will be here when you drift back in the morning. It always is. It always has been. Good night. May the hush of the galaxy be the hush of your room. And may the quiet river of stars guide you gently, steadily, all the way into rest.